Welcome to this lecture on Introduction to Differentiation by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, Prince. So today we are going to start with our new section unit, which is Unit 3, and that is about differentiation. Okay, so we have done limit, then we have done continuity. Now we will do differentiation. Okay. So let me just share the whiteboard with you all. So I am audible. My voice is fine.
Yes, sir.
Ye-
Okay, good. So this whiteboard is visible to everyone.
Yes, sir.
Good.
Yes,
So
sir.
yes, so we are going to start with our new unit, which is differentiation. So in this unit, we will define when we call a function to be differentiable, and then we will do some results like your algebra of differentiation, and then your chain rule, okay, which applies to composition of two functions. So all those things we will do in this section. Okay. So let us start with the. So first, let us see what we mean by differentiation. So you all know what does a derivative of a function at a point represents? Yes. So if I have some function, okay, and this is some point, this is point C, then what does this f dash C represents? Derivative of the function f at C. Yes.
Tangent at that point.
Yes, tangent at this point, right? Tangent to f at the point C, right? So derivative, we know this from our previous knowledge. The derivative of f at C represents the slope of the tangent to the function f at C, right? Yes, it represents the slope of the tangent. So if this is the tangent, okay, so this is my C, this is my tangent. Now if I want to find the slope of this tangent, how I will get this slope? So we pick any point x around this C, right? We pick any point, or you can pick on the left or right. So you pick any point x around this, so any point x, and then this will be your fx, right? And then you join these 2 points. You join these two lines, right? You have just now this, when this slope of this line will be equal to the slope of the tangent. Yes, when this slope of this line, so this is your point, say A, okay, this is your line A, this is your point B. So A का point क्या हो जाएगा? A is CFC and B is X FX. So the slope of the line AB will be, what is the slope of the line AB? Yes, slope of line AB will be equal to, बताओ,
So derivative हो जाएगा
x minus fc upon x minus c, right? x2 minus y1 upon x2 minus x1. ठीक है? So when the slope will be equal to the slope of this line, this tangent at A, कब होगा ये? जब हमारा ये x जो है ये this will approach to c, right? When this x will approach to c, so limit x tends to c, fx minus fc upon x minus c, right? Yes. So when should we call a function f to be differentiable at a point c? If this limit exists. अगर ये limit exist करेगा तो मतलब derivative exist करेगा at that point, right? क्योंकि स्लोप फिर टेंजेंट एग्जिस्ट करेगा. ओके, इज इट फाइन? So this forms the basis for our definition of derivatives. Okay, so let me just give you the definition now. This is the definition. This. So when b approaches to a, so I is any given interval, the function f is defined from I to R and sees any point in I. We say that a real number L is the derivative of the function f at C, matlab ki f dash C. So this a real number L is the derivative of the function f at C if for any given epsilon greater than 0, you are able to find some delta greater than 0 such that for any x belonging to I with this property that 0 less than x minus c less than delta, this property is satisfied. Fx minus fc upon x minus c minus L is less than epsilon. So basically what does this mean? It means that limit x tends to c, fx minus fc upon x minus c is equal to L, right? This is the definition of limit. What was the definition of limit? If I say limit x tends to c, fx equal to L, it means that for each epsilon greater than 0, we are able to find some delta such that 0 less than x minus c less than delta should imply fx minus L less than epsilon. अब fx की जगह पूरा ये है this term. So limit this is limit x tends to c, fx minus fc upon x minus c is equal to L. ठीक है? And in that case, we say that the function is differentiable. So if this limit exists, then we say that the function is differentiable at C and we write f dash c equal to L. So it's the real number ko we represented by f dash c. So basically our f dash c is equal to limit x tends to c fx minus fc upon x minus c provided it exists. Okay? Is it fine everyone? The definition of derivative. Is it clear? When we call a function to be differentiable, we call a function to be differentiable if this limit x tends to c fx minus fc upon x minus c exists. और limit exists का मतलब क्या है कि we are able to find some real number L such that for each epsilon greater than 0 there exists some delta greater than 0 such that for any point x satisfying the property that 0 less than x minus c less than delta, then we will have fx minus fc upon x minus c minus L less than epsilon. So in that case we call the function f to be differentiable at C and we denote the real number L by f dash c. So f dash c basically represents the derivative of the function f at c. Okay, so f dash c represents the derivative of the function f at c, and it is given by this formula limit x tends to c fx minus fc upon x minus c, provided this limit should exist. Okay, और लिमिट कब एग्जिस्ट करता है? इसी पॉइंट पे यस
सर
जब
जब
continuous
हर एप्सिलॉन के लिए एक डेल्टा मिल जाए
हाँ,
such that mod
LHL और RHL के टर्म्स में
LHL equals to RHL हो.
LHL इक्वल टू RHL हो, तो यहाँ पे इसका LHL क्या होगा? इसका LHL we know that limit x tends to c fx minus fc upon x minus c exists if and only both limit x tends to c positive fx minus fc upon x minus c and limit x tends to c negative fx minus fc upon x minus c exists and are equal. So दोनों exist करते हैं और equal होते हैं तब ये limit exist करती है, right? Yes. Yes. ये हम लिमिट में कर चुके हैं, ये लिमिट्स में, वन साइडेड लिमिट्स में, ठीक है. वी हैव ऑलरेडी
Yes,
डन लिमिट x टेंड्स टू c f x exists if and only LHL and RHL both exist and they are equal. So यहाँ पे LHL क्या है, क्योंकि यहाँ पे फंक्शन हमारा एक तरह से ये है पूरा, fx की जगह पूरा ये है. So this is our, so this term is called left hand derivative, oh sorry, right hand derivative. This is called right hand derivative and this is called left hand derivative. Okay, so one sided derivatives, you can call them one sided. Okay, so first is left hand derivative. LHT, so this is nothing but limit x tends to c negative fx minus fc upon x minus c. ठीक है. इसको और क्या फॉर्मूले से लिखते हैं? Yes, it is equivalent to limit so x को c से रिप्लेस कर देते हैं. ठीक है. So you will get, क्योंकि अब ये c से छोटा होना चाहिए because h is positive, so c minus h will be smaller than c, so that's why हम x को लेफ्ट से अप्रोच कर रहे हैं c के. तो यहाँ पे क्या आ जाएगा, यहाँ पे हमारे पास minus h. So this is also one of the formula. So generally we use this formula, right? ठीक है. Is it fine?
yes, sir.
ये फॉर्मूला, सो बेसिकली हमने क्या करा, वी हैव रिप्लेस्ड x बाय c माइनस h, और जो c माइनस यहाँ पे माइनस h इसलिए ले रहे हैं क्योंकि h को पॉजिटिव मान रहे हैं हम. ठीक है. यहाँ पे वी आर एज्यूमिंग h टू बी पॉजिटिव, सो h ये पॉजिटिव है. ठीक है. सो दैट्स व्हाई, बिकॉज़ वी वांट टू अप्रोच c फ्रॉम द लेफ्ट साइड ऑफ c. सो लेफ्ट साइड ऑफ c में क्या होगा, नंबर स्मॉलर देन c, सो दैट इज ऑफ, दे आर ऑल ऑफ द फॉर्म c माइनस h वेयर h इज पॉजिटिव. ठीक है. एंड सिमिलरली वी विल हैव राइट हैंड डेरिवेटिव. Yes, RHD. So RHD is equal to limit x tends to c positive fx minus fc upon x minus c. So this is nothing but limit h tends to 0, h greater than 0, f of c plus h minus f of c upon h. Okay, so basically we have replaced x by c plus h. Again, because h is positive, we are considering h to be positive, so c plus h is greater than c. So that means h को 0 पे ले जा रहे हैं, that means we are approaching to c from the right side of c, right? देखो नंबर लाइन पे your c is here, c plus h is here because h is positive, right? So we are h tends to 0 implies c plus h is approaching to c. ठीक है, right? Okay. So this is your c, this is your c minus h equal to x. Okay, so you are approaching here, so that means h is positive and h is tending to 0. Okay. This is your x. So you are replacing x by c plus h in this formula, and here you are replacing x by c minus h. Okay, so ये वाला formula generally हम use करते हैं to find the limits. Okay. So now we know that if LHD is equal to RHD, then f is differentiable at c. If LHD is equal to RHD at c, then f is differentiable at c, and the common value is the derivative of the function f at c, right? This is derivative of f at right. So if the two limits LSD is equal to RSD, then we say that the function is differentiable at C, and the common value is the derivative value of the derivative of the function f at C. Is it fine?
Yes,
Yes.
sir.
Question. Show that the derivative of the function f fx equal to x square for all x belonging to R is f is 2x for all x in R. So basically हमें ये शो करना है f dash x is equal to 2x. तो कैसे करोगे इसे? So you will pick any arbitrary point. So let C belong to R be any point. Now you will find the derivative of f at C. Consider, so you will find the limit. Consider limit x tends to C fx minus fc upon x minus c. So this is limit x tends to c. fx क्या हो जाएगा तुम्हारा? fx is x square. This is c square upon x minus c. So this is limit x tends to c x plus c x minus c upon x minus c. Now c gets cancelled. This is limit x tends to c x plus c. So this is equal to limit x tends to c x plus c by algebra of limits, right? ये लिख देना, ठीक है, algebra of limits यूज कर रहे हो तुम यहाँ पे. So this is equal to c plus c, which is 2c. So hence f is, क्योंकि ये लिमिट एग्जिस्ट कर रही है, पहले तुम्हें शो करना है लिमिट एग्जिस्ट कर रही है. डायरेक्ट मत लिख देना कि f dash c equal to this. ठीक है, फर्स्ट यू हैव टू शो दैट दिस लिमिट एग्जिस्ट, देन यू विल से दैट f dash c is equal to this. ठीक है, ये ध्यान रखना. डायरेक्ट यहाँ से ऐसे मत स्टार्ट करना कि f dash c is equal to this. So this is wrong, because first you have to show that this limit exists, then you will say that the function is differentiable or derivative of the f at c is equal to the value of this limit. So वो तभी होता है provided it exists. So पहले first you have to show the existence of this. So you should not start with like this f dash equal to, इस तरह से मत start करो, पहले limit से start करो. First show that this limit exists, then you will say that f is differentiable at c and f dash c is equal to 2c. Now since C belonging to R is arbitrary, it follows that f dash x is equal to 2x for all x in. Is it fine? Is it clear, everyone?
Yes, sir.
So यहाँ पे it is important, you should not start like this, f dash c equal to this. This is wrong way to start, ठीक है, क्योंकि you don't know whether this limit will exist or not. So you cannot say that the derivative of the function will exist or not. So जब derivative exist नहीं कर रहा तो ये dash लगा ही नहीं सकते, ठीक है. So this you cannot use it here. You first have to show the existence of this. When you will show the existence of this, then you will say that the function is differentiable at c and the derivative value of the derivative is equal to the limit. या एक लाइन यहाँ पे और ऐड कर सकते हो. This is equal to limit x tends to c fx minus fc upon x minus c, which is equal to c. So this, okay. So first show the existence of this. Okay. Is it fine?
सर हेलो,
Yes.
इसे एप्सिलॉन और डेल्टा की डेफिनेशन से भी प्रूफ कर सकते हैं सर.
हाँ सेम एप्सिलॉन जो लिमिट, लेकिन अब हमने ऑलरेडी बहुत कर लिया है, सो वी डोंट नीड टू गो इनटू एप्सिलॉन डेल्टा डेफिनेशन. अब हम अलजेब्रा ऑफ लिमिट्स यूज कर सकते हैं, ठीक है. वी कैन डू इट बाय, क्योंकि वही काम करना है यहाँ पे, तुम्हारा पूरा सेम चीजें आ जाएंगी पूरी जो लिमिट्स में लगाते हो, ठीक है, क्योंकि बेसिकली तो वही शो करना है लिमिट. फिर तुम्हें यहाँ पे 2c से स्टार्ट करना पड़ेगा, 2c लेके चलना पड़ेगा, ठीक है. बट now we have done enough of epsilon delta approach, so we don't need to go into that. We can directly prove it like this, unless you are asked to show by using epsilon delta definition. Okay, unless you are asked to show using epsilon delta definition, you don't need to go into epsilon delta definition. Is it fine?
Yes, sir.
यहाँ पे मतलब अपने मतलब ऐसा नहीं है कि हमने ये शो कर रहे हैं कि हम 12th वाला यूज कर रहे हैं, वी आर यूजिंग दिस अलजेब्रा ऑफ लिमिट्स, हम इस फॉर्म में ले आए, नाउ वी आर यूजिंग अलजेब्रा ऑफ लिमिट्स, अलजेब्रा ऑफ लिमिट्स, और ये हमने ऑलरेडी प्रूव कर रखा है at limit x tends to c x is equal to c, ठीक है. so we are using what we have done in our syllabus, it's not कि हम ऐसे ही arbitrary लिख रहे हैं, ठीक है. so we have developed so much theory that now we can apply them, ठीक है. so we are applying our theory that we have used here, ठीक है. so हम syllabus में ही हैं, we are not using anything extra, okay. but अगर एग्जाम में आ गया कि show using epsilon delta definition, then you will have to show it using epsilon delta definition. so then अगर इसको alternate using, चलो एक बार कर ही लेते हैं so that it would be good for you. Alternate using epsilon delta approach. so now क्योंकि epsilon delta approach में हमें L पता होना चाहिए, right? तभी तो लगा पाएंगे. so हमें L क्या होगा हमारे यहाँ पे 2c. so let c belong to R be any real number, right? and let epsilon greater than 0 be any positive real number. Okay, so now we have to find some delta corresponding to this. So consider, now you will have to start with this fx minus fc upon x minus c minus 2c. so L जो है तुम्हें पहले से पता होना चाहिए, ठीक है. so this is x square minus c square upon x minus c minus 2c. so now you will simplify it. सेम पूरा प्रोसेस वही होगा, कुछ ऐसा एक्स्ट्रा कुछ नहीं आएगा. ठीक है. so what delta we should choose? Yes.
Sir.
Then by the choice of delta, it is evident that fx minus fc upon x minus c minus 2c is less than epsilon whenever 0 is less than x minus c less than delta. Hence, by definition, so hence f is differentiable at c. Hence, f is differentiable at c and f dash c is equal to 2c. Since c belong to R is arbitrary, it follows that f dash x is equal to 2x for all x belong to. So this is how you could have proved using epsilon delta approach. Okay. Is it fine, everyone?
Yes, sir.
Let us do one more example. So अब क्या किसका करें? Question. Show that the derivative of the function fx equal to x cube is given by f dash x equal to dx square for all x belonging to R. So again, you will pick any arbitrary c belonging to R, right? So let c belong to R be any any real number, because we have to show it for every real number. Now we consider, we start with the limit x tends to c fx minus fc upon x minus c. So this will be limit x tends to c. अब ये क्या हो जाएगा? This will be x cube
X cube
minus c cube upon x minus c. So what is the formula of x cube minus c cube?
x minus c into x square plus c square plus xc.
Plus xc. So this is limit x tends to c, x square plus c square plus xc. Now apply algebra of limits. Using algebra of limits, it will be right. Using algebra of limits, right? So this is your c square plus c square plus c into c, so which is 3c square. Since limit x tends to c, x is equal to c. We know this result. So since c, oh sorry, hence f is differentiable at c. F is differentiable at c, and f dash c is equal to 3c square. Okay, since x belonging to, or c belonging to R is arbitrary, it follows that f dash x is equal to 3x square for every x in R. Clear? Is it fine?
Yes, sir.
Okay, चलो अब sin x करते हैं. Let us do it for sin x. So for the function fx equal to sin x,
सर
x
साइन 1/x ले लीजिए.
क्या,
साइन 1/x ले लीजिए.
वो थोड़ा ट्रिकी होगा, वो बाद में करेंगे, ठीक है. For
Yes.
the sin x, for the function fx equal to sin x, show that f dash x is equal to cos x for all x in R. Consider, okay, sorry, start with the proof. Let p belonging to R be any point. Okay, so consider limit x tends to c, sin fx
Sin.
minus fc upon x minus c. So what this will be, limit x tends to c, sin x minus sin c upon x minus c. Yes. Next, ये क्या हो जाएगा, sin a minus sin b का फॉर्मूला
2 sin 2 cos a plus b by 2 into sin a minus b by 2.
yes, sin x minus, इसको हम इस फॉर्म में लिख सकते हैं. So using algebra of limits, this will become this cos x plus c by 2, right, into limit x tends to c sin x minus c by 2 upon x minus c by 2. So this 2 we have brought in the denominator of this. Okay, so ये इस form में we have reduced it using algebra of limits. Okay, is it fine?
Yes, sir.
Now what is the limit of this? Because cos is continuous function, so you can take the limit inside, right? Continuous function में क्या होता है, limit x tends to c, fx is equal to fc. That means you can take the limit inside. Okay, this is your f of limit x tends to c x, right? So continuous, अगर f continuous है तो you can take the limit inside of the function. Argument में ले जा सकते हो limit. So यहाँ पे भी because cos is continuous function, so we can take the limit inside, right? Yes.
Yes, sir.
So this will be your cos c plus c by 2, right, into, and what is this limit?
1.
1. We have used the formula limit x tends to 0 sin x by x is equal to 1. So क्योंकि ये उसी फॉर्म का है, ठीक है, sin x by x का फॉर्म का, कि x को अगर c plus h से रिप्लेस कर दोगे तो it will become h by 2 upon h by 2. So h को 0 पे ले जाओगे तो it will come out to be in this form, right? ठीक है, so ये formula basically we are using this formula. x tends to c मतलब कि x minus c is approaching to 0. So this whole term is approaching to 0. This is also approaching to 0. So ये इस फॉर्म में आ गया, x इस फॉर्म में. So that's why we can use this limit. And since cos is continuous function, so continuous है इसलिए हम ये लिमिट ले पा रहे हैं अंदर. ठीक है, ये important है. We are taking this limit inside of the function. We are taking the limit into the argument of the function because the function is continuous. ठीक है, so that's why we can take this limit inside. So this is your cos c. ठीक है, is it fine? Since c belonging to R is arbitrary, it follows that f dash, sorry, पहले हमें ये शो करना है कि hence f is differentiable at c and f dash c is equal to cos c. Since c belonging to R is arbitrary, it follows that f dash x is equal to cos x for all x in R. Is it fine? So this is how you can prove the derivative. So पूरा ये approach ही रखना है, मतलब डायरेक्ट मत करने लगना कहीं भी, सेम पूरा ये इसी पैटर्न में चलना. So इस पे क्या नहीं आर्बिट्री पॉइंट, क्योंकि हमारी जो डेफिनेशन है दैट इज वो एक पॉइंट पे डिफाइंड है. तो हमारी ये डेफिनेशन है लिमिट की, दैट इज डिफाइंड एट अ पॉइंट. So we have to show at a point. So point पे show करके, but arbitrary point पे show कर रहे हैं, इसलिए we are able to show on the whole of domain, right? तो पहले point pick करना, just pick an arbitrary point, then show that this limit exists. और जब limit exists हो जाएगी, then you can say that the function is differentiable at that point, and the value of the derivative is equal to the limit that you are getting. Okay, and then because your c was arbitrary point, so then you can say that the derivative on the whole of domain will be the function. Okay, is it fine?
Yes, sir.
Yes, sir.
Okay, fine. तो जैसे हमने लिमिट्स के अलजेब्रा ऑफ वो करा था, क्योंकि अब ये भी दिस इज नथिंग बट लिमिट्स ओनली. सो यहाँ पे भी वी विल हैव अलजेब्रा ऑफ लिमिट्स. अच्छा, उससे पहले हमें एक रिजल्ट करना है. कंटिन्यूअस फंक्शन और डिफरेंशिएबल फंक्शंस आर कंटिन्यूअस. ओके, एवरी डिफरेंशिएबल फंक्शन इज कंटिन्यूअस. If f is differentiable at a point c, then the function will be continuous at that point c. Okay, so we are going to prove first this theorem. If f from I to R has a derivative at c, then the function is continuous at c. So हमें ये show करना है that the function is continuous at c. Given f is differentiable at c, to show f is continuous at c. So कैसे show करेंगे? Continuous show करने के लिए क्या show करना होता है हमें?
Limit exist करना चाहिए.
Yes, limit x tends to c, fx should be equal to fc. That is, if I pick any arbitrary epsilon, then I will be able to find some delta such that fx minus fc will be less than epsilon whenever x minus c is less than delta, right?
Yes, sir.
So let epsilon greater than 0 be any real number. So we start with any real number. So now we have to find some derivative. Okay, sorry, we have to find some delta such that fx minus fc is less than epsilon. वो delta कहाँ से
सर
है?
हम कर सकते हैं. सर हम लोग डायरेक्टली भी कर सकते हैं. सर विल टेक टू केस व्हेन x नॉट इक्वल्स टू c एंड व्हेन x इक्वल्स टू c.
नहीं, केस में क्यों जाओगे तुम? यहाँ पे केस की जरूरत नहीं है. you want to say using limit?
Yes, sir.
ये कहना चाह रहे हो ना हम, लेकिन प्रॉपर प्रूफ करेंगे ना इसका, इससे तो कर ही सकते हैं हम, because this exists.
Yes, sir.
तो इसको हम ये कर सकते हैं, इसको because if we have to show, what we can do is we can use this formula ना, तो वो इसमें भी करेंगे, ये कर सकते हैं, fx minus fc can be written as x minus c into fx minus fc upon x minus c, provided x is not equal to c, right?
Yes.
So
Yes,
then
sir.
you will say that limit x tends to c, fx minus fc should be equal to, by algebra of limits, limit x tends to c, x minus c into limit x tends to c, fx minus fc upon x minus c. Now this limit exists, so this limit exists, and what is the value of this limit? It's because
Zero.
ये कुछ भी हो, but this is going to 0, so it will be 0 into f dash c, so this is 0, so this will come out to be equal to this. So एक तो approach ये है, but let us do by epsilon delta definition. Proof कर रहे हैं ना, तो उसको epsilon delta definition से try करते हैं, ठीक है?
Good. Yes.
अगर x equal to c लोगे तो fc minus fc हो गया, which is coming out to 0. So in either case you will get limit x tends to c, fx equal to fc, right? But let us take the epsilon delta approach. Okay, उससे try करते हैं. Let epsilon greater than 0 be any real number. Consider for any x, consider for any x not equal to c. So same चीज करेंगे यहाँ पे हम, वही same बिल्कुल, या पहले चलो डिफरेंशिएबिलिटी का यूज कर लेते हैं. So then we can take delta also. Since f is differentiable at c, so there exists delta greater than 0 such that fx minus fc upon x minus c minus f dash c is less than epsilon whenever 0 is less than x minus c less than. Is it fine? Because your f is differentiable at c, so there will exist some delta greater than 0 such that fx minus fc minus f dash c is less than epsilon whenever your 0 is less than x minus c less than delta. So mark it as star. Now for any x not equal to c, consider fx minus fc. Somehow we have to bring it into this form, तभी ये less than epsilon show कर पाएंगे ना. So this is fx minus fc upon x minus c into x minus c. This can be, again we can bring it into this form, minus f dash c, okay, plus f dash c upon x minus. This is your fx minus fc upon x minus c minus f dash c, okay, plus f dash c into x minus c. So this is,
Sir.
yes,
सर इसे मॉड से बाहर कैसे निकाल सकते हैं?
किसको?
सर f dash c को, oh sir, now it's correct.
ये triangle inequality use कर रहा है.
Yes sir. Yes sir, now it's
Okay, so this is less than epsilon, right? Whenever 0 is less than x minus c less than delta. Okay, so this is less than epsilon plus f dash c mod x minus c whenever 0 is less than x minus c less than. अच्छा डेल्टा स्टार कर दो क्योंकि डेल्टा हमें अलग से चूज करना होगा. ठीक है, so make it as delta star. So what delta we should choose? So what delta we should choose? Yes, delta equal to minimum of delta star and
Epsilon upon epsilon plus f dash c.
f dash. ठीक है, so because this is also positive, this is also positive, so ये ले लेंगे, then by the choice of it is evident that fx minus fc is less than epsilon whenever x minus c is less than delta. Okay, that is f, hence f is by definition of continuity f is continuous at c. ठीक है, so this is one proof. Alternatives that जो अभी हमने बताया था, so this is by epsilon delta approach, so you can prove it like this. थोड़ा complicated हो जाता है epsilon delta approach से, but you can always prove it using epsilon delta approach. लेकिन हम ज्यादा करेंगे नहीं epsilon delta approach से, वो बस मैंने एक करके दिखा दिया कि किस तरह से हम आ सकते हैं वापस अपने उस पे. ठीक है, बाकी अब सारे प्रूफ जो है हम डायरेक्ट ही करेंगे, we will not use epsilon delta approach उनमें. Is it fine?
Yes, sir.
डायरेक्ट प्रूफ बुक में दिया हुआ है, वो देख लेना, सेम है जो अभी मैंने बताया कि यू कैन रिप्रेजेंट एफ एक्स माइनस एफ सी, या अल्टरनेट प्रूफ लिख ही देते हैं. चलो, so this is your alternate proof. ठीक है, so इसमें क्या we started with any x not equal to c, so fx minus fc को we represented in the form fx minus fc upon x minus c, so because we are taking x not equal to c, so that's why we can multiply and divide. यहाँ पे भी हमने वही चीज करी है, because we are taking x not equal to c. ठीक है, so then that's why we can take this, bring this into denominator, otherwise इसको denominator में नहीं ला सकते x minus c को. ठीक है, so we have to take x not equal to c, so बस यही पर्पस है x not equal to c लेने का. so it is coming out to be, अब क्योंकि इसकी लिमिट एग्जिस्ट करती है, इसकी लिमिट एग्जिस्ट करती है x टेंड्स टू c, so इसकी लिमिट विल एग्जिस्ट एंड इट विल बी इक्वल टू limit of this into limit of this, which is coming out to be 0. So limit x tends to c, fx equal to fc, so f is continuous at c. Fine.
Yes, sir.
इसी तरह डेरिवेटिव डिफरेंशिएशन में हम ज्यादातर प्रूफ इसी तरह से करेंगे अपने, यूजिंग अलजेब्रा ऑफ लिमिट्स. ओके, वी विल नॉट गो टू इनटू एप्सिलॉन डेल्टा अप्रोच, बट वी कैन ऑलवेज प्रूव हैव अ डायरेक्ट प्रूफ यूजिंग एप्सिलॉन डेल्टा अप्रोच, जैसे अभी करा है हमने. लेकिन वो थोड़ा कॉम्प्लिकेटेड हो जाता है, उतना हमें नेसेसिटी है नहीं, क्योंकि वी हैव ऑलरेडी डेवलप्ड सो मच ऑफ थ्योरी, सो वी विल यूज दैट नाउ. Okay, so we have seen two functions, so we have seen that differentiability implies continuity, right? Is the converse true?
No, sir.
Example?
Mod x.
Yes, mod x. For example, fx equal to mod x, it is continuous at
0.
x equal to 0, but is not differentiable at x equal to 0. ठीक है, so differentiability show कर लेते हैं कि it is not differentiable at x equal to 0. ठीक है, so continuity we have already seen, so we have already एग्जाम में कर लेना प्रूफ इसको अगर आ जाए तो. we have already seen that fx equal to mod x is continuous at x equal to 0. now claim f is not differentiable at x इक्वल टू 0। अब हमारा fx डिफाइंड किस तरह से है? fx इज इक्वल टू x if x is greater than equal to 0 and minus x if x is less than 0, right? तो इसके लिए क्या करेंगे? we will find LHD and RHD. ठीक है, so LHD is limit x tends to c negative fx minus fc upon x minus c. This is limit x tends to, या इसको उस फॉर्म में ले लेते हैं, ठीक है?
Limit h tending to 0.
Limit h tends to 0, h positive, f of 0 minus h minus f of 0 upon minus h.
Minus h.
So because our h is positive, ये ध्यान रखना, ठीक है? So this is f of minus h minus f of 0 upon minus h. So this will be f of minus h will be, yes, f of minus h.
H.
This is
H.
whenever x is less than 0, it is minus of this. So minus of minus h minus 0 upon minus h. So this will come out to be
Minus 1.
minus 1. Okay. So this is coming out to be minus 1, and when you will find RHD, which is your limit h tends to 0, h greater than 0, f of h minus f of 0 upon h. So this will come out to be plus 1, right? LHD is not equal to RHD. So hence limit x tends to c 0, fx minus f0 upon x minus 0 does not exist. Thus f is not differentiable at x equal to 0. Okay, so we have shown that this function fx equal to mod x is continuous at x equal to 0. This we have already seen in our previous lectures, and now we have shown that it is not differentiable at x equal to 0. Hence continuity need not imply differentiability. A function which is differentiable has to be continuous, but a function that is continuous need not be differentiable. Okay.
Yes, sir.
Yes, sir.
Okay, so this much is enough for today. Any questions from anyone? Okay, so as there are no questions, let me end this class. So bye everyone. Have a good day.
Thank you, sir.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.